Okay, hello everyone. Mr. Schultz here, coming to you live from his classroom at extremely way too late of an hour. But anyways, so I wanted to do this video to get us going on the Unit 5 practice day over conditional statements. So without further ado, let's jump in. Okay, for the first two, we're identifying patterns. And so we need to figure out what's going on. So I'm going from 3 to negative 3 to 6, 6 to negative 12, negative 12 to 24. What the heck could I be doing each time? I mean, I could try seeing if I see a pattern on adding. 6 minus negative 3, well, here I'm adding 9. Negative 12 minus 6, well, now I'm subtracting 18. Negative 12 up to 24. I'm adding 36. I mean, that still doesn't help me with the pattern here. So there's not like a set thing I'm doing each time. So I'm going to erase that. That's not really helpful. What about multiplying? Negative 3 times what gives you positive 6? Times negative 2. 6 times negative 2 gives you 12. Negative 12. Negative 12 times negative 2 gives you 24. So 24 times negative 2 is going to get us negative 48. There's our answer. Okay, so now we have this octagon with diagonals drawn through it. So let's try our best attempt at drawing an octagon. Good enough. Okay, so let's see. We started at this corner and went there. Then we went to that corner. Then we went to that corner. What's going to be next? Well, now we're going to go to that corner. We're just going to different corners. Okay, complete the conjecture. The product of two negative numbers is blank. Two negative numbers. I need to try all kinds of possibilities, both even and odd numbers. They have to be negative, but I'll need to do even times an even, and odd times an odd, and even times an odd. And then see what I find in common. So let's do two even numbers. Negative 2 times negative 4 gives us positive 8. Let's do two odd numbers. Negative 1 times negative 3. That gets us positive 3. And then I need an even and an odd. Well, how about negative 5 times negative 6? That gets us 30. What's something that you see in common with all three of these values? They're all positive. Okay, number 4. Show the conjecture is false by finding a counterexample. Okay, on this one, read the directions, please. It's not asking you to tell me what the hypothesis and the conclusion are. It's not asking you to tell me whether it's true or false. It's telling me it's false. I have to find a counterexample. Several of y'all on your day one assignment said false. No, really? It tells you that. Show it's false. Or you told me what the hypothesis and the conclusion were. That's great. But that's not what it asked for. Make sure you read the question and give what it asked for. Okay, it says if AB plus BC equals AC, then B is the midpoint of AC. Does B have to be the midpoint of AC for this statement right here to be true? Let's look. Let's draw us a line here. So this is A, B, and C. Let's say this is, the whole thing is going to be 5. AB, we're going to say is 1. BC is 4. Well, if AB is 1 plus BC is 4, that gives us 5. This is true, but is B the midpoint? No, B is not in the middle. So that makes this statement false. This picture is good enough to be our counterexample. Now they ask us to identify the hypothesis and the conclusion. The angle is obtuse if its measure is 107 degrees. What word signifies the hypothesis? If. So whatever comes after if, that's going to be our hypothesis. The other part is our conclusion. An angle is obtuse. Notice I do not underline the word if. Number 6, write a conditional statement from the Venn diagram. Okay, which one is always our hypothesis? Not hypothesis, our hypothesis. Which one's always the hypothesis? The small circle. The big circle is always your conclusion. So we could say if a shape is a square, then it is a rectangle. Number 7, determine if the conditional is true. If it's false, give a counterexample. Or the statement says, if a figure has 4 sides, then it is a square. Is a square the only thing that has 4 sides? No. What about a rectangle? How many sides does a rectangle have? It has 4 sides, but this is a rectangle. It's not a square. So what does that mean? That means this is false. Okay. For 8, 9, and 10, we are given this statement. If a number is divisible by 3, then it is divisible by 9. We have to turn that statement into the converse, inverse, and contrapositive. So let's first identify our hypothesis. Well, it's going to be a number is divisible by 3. The conclusion would be it is divisible by 9. So for converse, what direction do we go for converse? If Q, then P. So if we need our noun is a number. If a number is divisible by 9, then it is divisible by 3. What do we think about that sentence? True or false? That sentence is true. If it's divisible by 9, then it has to be divisible by 3. Because 9 is 3 times 3. So that's true. Okay, the inverse. The inverse is the one with the nots. If not P, then not Q. So we negate everything. If a number is not divisible by 3, then it is not divisible by 9. So if it's not divisible by 3, then it's not divisible by 9. That's true. And then we have the last one, contrapositive. That's if not Q, then not P. So I flip and negate. If a number is not divisible by 9, then it is not divisible by 3. Okay, what do we think of this one? If it's not divisible by 9, then it's not divisible by 3. That one would be false. You're like, but how? How is it false? Well, think of 12. 12 divided by 9 is not a whole number. That's like 1.33 repeating. But 12 divided by 3 equals 4. So it's not divisible by 9, but it is divisible by 3. Okay, so there's the front of the practice day. Let's flip over to the back. Use a conditional statement to write a converse and a biconditional statement. If Greg has the fastest time, then he wins the race. What is our hypothesis? Greg has the fastest time. The conclusion would have to be he wins the race. So remember, converse is if Q, then P. So if Greg wins the race, then he has the fastest time. For biconditional, biconditional is the one that's P, if and only if Q. So Greg has the fastest time if and only if he wins the race. Okay. Keeping it moving. So they want us to identify the property that justifies each statement. Now, I realize we haven't exactly gone through these this year. We haven't talked about our properties. However, if you pay attention, you should be able to get these on the assignment. Okay, number 12, AB equals AB. Well, what does that look like? Almost looks like somebody's looking in a mirror. If it looks like you're looking in a mirror, it will be the reflexive property. So when it looks like you're looking in a mirror, it is the reflexive property. So AB equals AB is reflexive. Angle PQR is congruent to angle XYZ, and angle XYZ is congruent to angle JKL. So PQR is congruent to JKL. When it's long like this, and you have two parts, 1, 2, with the and in the middle, that makes this the transitive property. Think of it like you're in transit to your final answer. You have to stop at XYZ on your way to JKL. But eventually you get there. So when it's long like this, it's with two pieces with the and, that's the transitive property. 14. The measure of angle WXY equals the measure of angle CDE. So the measure of angle CDE equals the measure of angle WXY. This is called the symmetric property. Think of it like you fold it on the word so. The CDEs match up, the WXYs match up. That's symmetric. Okay. Now these next few are going to be like a review. The next three are going to be almost like a review. From unit 1 all the way back to unit 1. That's okay. Review gives us more power. Okay. L is between K and M. Draw a picture. Aye, aye, Captain. I shall draw a picture. L is between K and M. It says that KL is 43. KM, the whole thing, is 61.5. Find LM. How can I figure out what LM is equal to? We'll subtract. I know the whole, I know a part. Let's subtract. 61.5 minus 43. Let's see, that's going to be 0.5. 11 minus 3 is 8. 18.5. So LM equals 18.5. Okay, Julia wants to cut a piece of fabric so that one piece is 3 times as long as the other. If the total length of the fabric is 1 yard, how long is the smaller piece of fabric? Convert your answer to inches. Oh, they don't want the answer in yards. They want it in inches. Well, what do we know about that? 1 yard is equal to 36 inches. So when we draw our picture here, she's got her fabric. And the whole thing here, let me do this in red. Actually, let's do it in green. The whole thing, come on, is 36. Now she's gonna cut it. Let's say she cuts it, oh, I don't know, right here. So that one piece is 3 times as long as the other. So if this is X, then that means this has to be 3X. Now we have to find X. What does this go back to? Part plus part equals whole. X plus 3X equals 36. X plus 3X is 4X. Divide by 4, and you get X equals 9. So X is 9. If we want to find this other piece, 3 times 9 is 27. What does it ask for, though? It asks for the smaller piece. Well, that's going to be 9 inches. Okay, there's that one. Last one. A museum exhibit is split into a section of artwork from the Renaissance period and a section of artwork from the Impressionist period. The entire exhibit has an angle of 66 degrees. So the whole thing here, come back, the whole thing right here is 66 degrees. Find the value of X. Well, again, this goes back to part plus part equals whole. So 2X minus 1 plus X plus 1 equals 66. Now we want to combine like terms. 2X plus X gives us 3X. -1 plus 1. Those cancel. So 3X equals 66. Divide by 3. And we get X equals 22. That's all they ask us to find. The value of X. We're done. Okay, so that is the lesson for the practice day. We looked at conditionals, a little bit of inductive reasoning, and then we reviewed some from chapter 1. So the assignment looks really similar because it is a practice day. If you have any questions, just shoot me an email or come see me in class and I can help you out. Until next time, this is Mr. Schultz signing off. Remember, you are awesome and you were created to do wonderful things. Always believe.